Hey guys, welcome back to Algos Made Simple. This one here is a little bit on the more medium to difficult side, but I think once you see the simplistic solution we're going to utilize for this one and really wrap your head around it conceptually, you realize that it's not that hard at all. So with that being said, let's go ahead and dive right into it. It's Leetcode 33 Search in Rotated Sorted Array. There is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index k, where 1 is less than or equal to k is less than nums.length, such that the resulting array is nums index k plus 1, nums index n minus 1, nums index 0, nums index 1, nums index k minus 1, 0 indexed. For example, 0, 1, 2, 4, 5, 6, 7 might be rotated at pivot index 3 and become 4, 5, 6, 7, 0, 1, 2. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it is not in nums. You must write an algorithm with O log n runtime complexity, and that's the kicker. I would let the interviewer know, okay, I understand I'm getting a list of nums, and I simply just want to see if this target is entered or not. But I have to do it in O log n, so I can't just iterate through it, so I need to utilize some sort of binary search or some sort of way to only have to look at, half the numbers or at least less than the full set of numbers. So I understand what's being asked of me. It's pretty clear. So how are we going to do it? Well, looking at this example here, you got 4, 5, 6, 7, 0, 1, 2. Target is 0, and so your output is index 4. Well, again, very easy on the surface level to say, okay, is this target in here? Well, let's look at 4, let's look at 5, let's look at 6, look at 7. Oh, there's a 0. The target's in there. Done. O of n. But we have to be better than that. So what can we do that's better than that? Again, we've kind of led into it earlier, binary search. So binary search, if it was a fully sorted array like this one in the example here, 0, 1, 2, 4, 5, 6, 7, you would simply say, okay, is the target greater than 4? If it is, we'll search over here to the right of it. Is the target less than 4 or less than or equal to 4? If it is, we'll search the left side over here to the left of it up to the middle point. So very easy if it was a fully sorted array, just to utilize binary search would be O log of n. Everybody goes home happy. But we don't have a fully sorted array in this one. We've got 2 of them combined into 1. So what do we need to do? The first thing we got to do in our game plan is we're going to need some way, because if we knew, hey, we're in array 1 over here, then at that point we would know everything to the left, what it's supposed to be, and everything to the right, what it's supposed to be, given the number, the midpoint, or whatever. And same thing for this array 2. So we need to figure out what array we are in. What array are we in? So how do we figure that out? Well, if nums at mid is greater than or equal to nums at left, so that means this value here on your far left is less than your middle value. That means you're still ascending, ascending, ascending. It's completely sorted, going up, 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 up. You're a part of that original left or first array. Now, if 0 was our midpoint, then the nums at mid would be less than the nums at left. We know that midpoint is part of this right array, this second array. So that's what we do to utilize that and to figure that out. So I'll go ahead and put that on there. It means array left. Otherwise, if nums at mid, I'm going to put this down here because I'm just kind of keep it separated. If nums at mid is less than nums at left, then we are in array right. So what does that matter? How does that help us? So once we know that we're in an array, which array that we're in, then we can utilize target and do a modified binary search here where we say if that target, so if target is greater than the number at the middle, so if this target's greater than the number at the middle and we know that we're in this array right here, then we know that everything to the left of nums at middle is going to be descending. It's going to be less than the number at middle because we know the number at middle is greater than the left and it's part of that array. So with that being said, if this target is greater than nums at mid, we don't need to search this side. We need to search the right side. Okay, well, what else would make us search that right side? If the target was less than the numbers at mid, so it's less than this one, at that point, we don't know if the number could be over here because it's descending, or it could be in this brand new array. We don't know what's included in that. So how do we narrow that down? Well, if this target is less than the number at the left, then we know to search the right. So, or target less than nums at left. So again, if it's greater than nums at mid, then we know to search the right, because everything to the left of this one, because we're in this array, is descending. And then if the target is less than the nums at left, we know the numbers in this left array only get higher, so we need to search the right. Alright, so if we're in array right, so if this nums at mid, say we're here, is part of the second array, or array right, then what we do on that one is we take this target and we simply say if target is less than nums at mid, so the target's less than nums at mid, then we know we're going to be searching the left. So if it's less than this number right here, yeah, if this target is less than nums at mid, we're going to be searching the left side, because we know that everything to the right of nums at mid, since we are in the right, we're in a brand new array, we know everything to the right of it is going to be ascending, ascending, ascending. So if this target is less than the number at mid, there's no way anything to the right is going to help us out. So we have to search the left. Okay, the other way to know is if this target is greater than the number on the right. So if this target, so if say the target is greater than nums at mid, so it's greater than this, but it's also greater than this, well, the only place we could have a better number then is over here on the left. So we're going to search the left. So those are our two ways to figure out if we're going to search the left. And again up here, this was to search the right. And then if either, in those circumstances, if neither one of these are correct, or whatever, neither one of these are true, so if this target is less than the numbers at mid and the target is greater than the nums at the left, then we're going to search the left. And same thing over here, if the target is greater than nums at mid, so this target is greater than this number, if our mid was 0, target's greater than it, and our target is less than right, then we know it just makes sense that we're somewhere in here. So if neither one of these are true, search the right. That's the entire problem, and one thing you want to put in the game plan after searching, or after these conditionals, then we want to return -1 if we make it that far. It says it's just not in there. So that's the entire problem, guys. Again, it's not bad at all. So how do we code it up? We just have to really make sure we stay true to our game plan here when we're coding it up. So we're going to say search, and it's going to take nums, and it's going to take a target. And what we have to do, it's a modified binary search. So you know binary search has a left, it could be at index 0. It's got a mid, which will be length of nums -1, and with the round division operator. And then you'll have right, which will equal the length of nums -1. So we have our indexes there. So the next thing we're going to do, what array are we in? Okay, if nums mid, we talked about this, if nums mid is greater than or equal to nums at left, the reason you do that is because you may have a really, really small list. If that's the case, this is the case, so let's put this out here. If that's the case, then we are in array left. Okay? If that's the case, we're in array left. Alright, if that's not the case, so further down here, I have to move this to a whole brand new page. Alright, coming back here, I'm going to bring our game plan down too, so we have sight of that. Okay, so, and then bring this back up. Alright, so what we're looking here is we've got our array left. If that's not the case, if nums at mid is less than the nums at left, And like we talked about, it's our else statement for right here. Like we talked about, it'll be array right. And again, get this else back online. Okay, so we know we've got our first part done. We know we're going to be able to figure out if we're in array left or array right. So again, what did that mean if we were in array left? If we were in array left, it meant that every number to the left of this midpoint was going to decrease. If we were in array right, it meant that every number to the right of that number was going to increase. That's what we're taking out of there. So then all we have to do with that information, we start to utilize our target value against it. So we can say if target is greater than nums at mid, okay, then we know if that's the case, we're going to search to the right because everything to the left is descending. Okay, our other thing we talked about, or, so if the target is, and if you get stuck, you can just say, okay, well, what would happen if the target was less than the nums at mid? So my target, I'm in this left sorted, my target is less than the num at the mid right here. Well, in that case, I don't know which side to go on. How would I know it? Well, is my target less than the left? If it's less than the left, I'm over here to the right. So very, very simple there, guys. Just one you can start thinking through if you get stuck, as long as you kind of made it this far and know what's going on. So if target is less than nums at left, all right, we are going to search the right. And what search the right looks like, very, very easy. We'll set the index to the midpoint, because remember we have to return the index, not just seeing if it's in there. We're going to say for num in nums, and it's going to be from midpoint on, because we're searching the right, from midpoint on. So again, don't have to search the whole thing, we're only searching, you know, about half of it, whatever. If the number equals the target, we'll return the index. Otherwise, we'll do index plus equals 1 and keep bumping with that index until we hopefully find it. All right, so the next thing, if neither of these are correct, if target is less than nums at mid and it's greater than nums at left, then you know we're searching the left. So you can just put an else statement here. You don't have to spell that out unless it helps you to. You'll say search left, and how you search left is very similar. Left, or I'm sorry, index is going to equal the left. So you're starting off at 0, and you just say for num in nums, and you'll do from left, so the start of it, to mid plus 1, because it could be your midpoint. And we want to include that over there just in case. We want to keep including the midpoint in these. And you'll say same thing over here. I'll go ahead and copy paste it. Well, I'm going to copy paste it where it's actually going to look decent. If num equals target, returned index, index plus 1. All right, so if we have it on the array left, we would be done. This would guarantee us that we're going to either find it or not find it if it's on the left. So again, this is our if statement right here to see if it's on the left. This is our if with a target. So you got some nested ifs here, which can get a little confusing, but not too bad. So now we're coming here. We're out of that. So if we are not in the array left, we're in array right. Nums mid is less than nums left. So what do we do in this case? Well, again, now we know that every number to the right of the midpoint is going to be ascending or greater than the midpoint. So what we can say is if target is less than the numbers at mid, if that's the case, because we know everything to the right of target is going to be higher than what the midpoint is. Everything to the right of nums mid is going to be greater than what midpoint is. So if target is less than that already, then we know to search the left side. Or if the target, so to say the target is greater than nums at mid, so we're on this right side here, and target is greater than the nums at mid. So we don't know if it's going to be this 1 or 2 or this 4, 5, 6, 7. If we look and see that the target is also greater than the number on the right, then we definitely know we have to search over here to the left. That's our only hope. So, or target greater than nums right. Okay, that's going to be search left. Let me copy paste it. It's the exact same thing. And then if that's not the case, if both of those are wrong, which we gotta come down here to another page here. Again, this code is a little bit longer than I would like, but I think it does a great job of spelling it out and making it very simplistic. You can definitely find ways to shortcut this and find ways to make it smaller and make it more convenient, but I think it does a great job of spelling it out, and it's not too long. But anyway, so we'll say if that target is greater than nums at mid and the target is less than the nums on the right, so target is greater than this num at mid or in the right array, so it's greater than this, but it's also less than this, then we have to search the right. It's got to be one. It's got to be something in here. So with that being the case, we'll search right, and I'm going to copy paste what the search right looks like. So else search right, index will equal mid for num and num's mid and on. If num equals target, return index plus equals 1. So then getting out of that, if we go through this whole thing, so staying in line here, if we get out of all of these constraints and we were not able to return an index, then we're going to return -1. It's not there. It's not part of it. So again, guys, a little bit longer than I would have liked for this code, but I think this spells it out really nice. It's O log of n. It's a modified binary search. You're not having to go through the whole data set. You're just picking either whether you're going to go through one of the arrays or the other arrays. Again, it doesn't mean it's going to be necessarily half, but you're definitely cutting down what you have to do here, how many numbers you have to go through. So again, you need to figure out what array you're in, because that will let you know if the numbers to the left of that midpoint are all descending, or if the numbers to the right of that midpoint are all ascending. It just gives you the keys you need to be able to start comparing this target number and figuring out what goes on from there. So again, thanks for watching, guys. Hopefully this simplified this one as much as possible. If you have a simpler way to do this one, or you think I didn't explain something clearly and you've got a more concise, clear explanation, please let me know in the comments. Please like and subscribe if you're enjoying these, or if you're getting a chance to watch these. And we're going to keep going through. Thanks, guys.